Looks like we're live.
Can you see something?
Yep. As everybody can hear me?
Yeah, we can hear you properly.
All right, great. I can't see you guys, so that's always challenging when we do these things. My name is Bill Kennedy. I'm the managing partner over at Ardent Studios. I was actually just in India a couple of weeks ago at GopherCon India. Your city is absolutely beautiful. I really enjoyed myself and enjoyed everybody that I met. Hopefully there's some of you there that were at the conference. So I'm going to try to do the impossible right now. I'm going to try to show you how Go can be used in an object-oriented way in 20 minutes. When we teach these lessons in the training, we usually get a good hour and a half to go through this material. I've tried to cut it down into 4 examples to be able to give everyone a general idea of how the language can be used to implement object-oriented paradigms. So I'm going to share my screen and start going through some code. There we go. All right, so everybody can see that?
Yeah, we can.
All right. So that's okay. And that's all. That's a good size. Sorry. And that's a good size for everybody?
Yeah.
All right. So this piece of code right here is going to show you how. Hello?
Yeah.
I'm getting some feedback. So this piece of code here is going to. I'm getting feedback on your side.
Yeah. I'm just gonna go into mute or something.
Yeah, mute your mic. All right, great. All right, so this piece of code here. This piece of code here is going to show you how we can take a type and add behavior to it. Go has something that's called methods. So here's a type. Type is user. It has these 2 fields, name and email. And you're going to see following this code, this type here, 2 methods. A method named notify and a method named change email. Now this notify method has what we call a value receiver. Methods in Go have a receiver. That is the value that is going to be used, a value of that type that can be used to call the method. So this notify method is using a value receiver off the type of user. This method here is using a pointer receiver off the type of user. So when this method is executed, we're always working with a copy of the value that the caller is using to make the method call. Anytime we call change email, we have a pointer receiver. We're sharing that value that the caller is using to make the method call. Let's quickly look at how we can create a value and call into one of these 2 methods. So here we have in main this line of code on line 31. We're creating a value of type user. We're initializing it. And now we have a variable named Bill. Bill is a value of type user. And now from that value of type user, the variable named Bill, we say bill.notify, and now I'm able to execute the notify method off of that value. I'm also able to execute the other method that we created, named changed email, off that value of type Bill. Even though at this point the method here receives a copy, and this method allows us to share it. It doesn't matter if I'm working with a value or not. Go will adjust that value to be able to make the call. The same thing here on line 37. This time I'm creating a user value as well. But what I'm getting back when I create that is a pointer. That's what this operator does. It's bringing back an address to where that value is. So Bill is a value of user, but Lisa in this case is a pointer of type user that's pointing to that value that we created. Again, whether I'm using a value or a pointer, I'm able to call both methods. And Go will make sure that when I call notify, I'm working with a copy of that value. When I call change email, I'm sharing it. I'm working with a pointer to that. I can make changes at that point that get reflected outside of the method call. And so this is how we can add behavior to our types. So now that we can define a type, declare a type, we give it some fields, we can declare behavior behind it, and we can create values of that type and call methods. The next step is being able to implement polymorphic code. So code that can take a value of any concrete type and be able to execute different behavior. Let's see how we do that in Go. So Go has a special type called an interface type. This is it right here. And so we're creating a type of interface. We've given it the name notifier, and we've declared here that the notifier interface has a single method named notify. In Go, when we declare an interface that has a single method, it's common to end the name of that interface with the ER suffix. So now I've declared this interface, and now I have a struct of type user. It's the same struct that we looked at before. And let's look at this method now. So here's the notify method. In fact, the notify method, the signature, which takes no parameters and returns no values, is identical to the signature of the notify method inside the interface. And so now with this method, using a pointer receiver, the implementation of this method is now giving us the ability to say we implement this interface. And that's all we have to do in Go. We don't have any special keywords that we have to worry about like implement. We don't have to do anything special. All we have to do is say, let me declare a method with the same signature. In this case, I'm using a pointer receiver to do that. And now I have implemented the notifier interface. If we look at some code here in main, I want to show you two things. I want to show you down here on line 40 first before we look at main. Here on line 40, I have declared a function called send notification. And this function accepts values of the interface type, values of type notifier. So I can only pass values into this function that implement the interface, only values that implement the interface. And when I do that, I have polymorphic behavior because now I'm calling, in this case, the notify method off of the interface value. So I can create thousands of types that have values that now implement this interface, and this function here can execute all the different behavior for any concrete type that implements that interface. So now if I come back to main, you can see here I'm creating a value of type user. I'm getting back the address, so U is a pointer variable, a pointer of type user, and I'm able to pass that pointer variable into the send notification function. Why? Because pointers of type user implement the interface. If we go back and look at the implementation of the notify method, I am using a pointer receiver to implement the method. Now Go has in the specification a set of rules around method sets. I don't have time to get into method sets, but I will tell you one thing. If we use a pointer receiver to implement the interface, then only pointer values implement the interface. In other words, I've used a pointer receiver here to implement this notify method. The notify method has the same signature as the interface. But because I've used a pointer receiver, in this case, only pointers are going to satisfy the interface. If I try to pass a value of this type into this function here, I will get a compiler error. Now, we can have a much larger conversation around method sets. But for now, let's just leave it at that. You have a pointer receiver, then only pointer values implement the interface. And so now we have code here that is polymorphic. I'm going to run this, and we're going to see here that through this interface variable, I'm able to execute the behavior notify off of this type. Now I can come in here, create a new type, say I call it struct, just give it the same fields for now, and I can turn around and say, okay, let's also implement the notify interface for this type called Atom, using a pointer, admin, using a pointer receiver. So here we go. That's it. I'm done. I created a new type. I've implemented this method. I'm using a pointer receiver of that type. And now values, really pointers of type admin, also implement the interface. Here we go, creating a value of type admin. I'm getting back a pointer. That's that call to send notification. Here's the second call using a pointer of a different type. I run it, and here we go. Send notification is executing the behavior for pointers of type user and for pointers of type admin. I have polymorphic behavior here. So the method is the driving force behind this. The method allows us to bind behavior to the type, and when that method implements an interface, depending on the receiver type, in this case, I'm just sticking to pointer receivers because we don't have much time to get into large detail about method sets. But sticking with the pointer receiver, now anytime I'm dealing with a pointer value, I implement that interface. I can pass it into this polymorphic function and get that polymorphic behavior out of my code. Now the last piece that I want to talk to you about with object-oriented programming, because we have types, we can add methods, we can implement polymorphic behavior. The last piece is, can I take a type that exists and extend it? How can I do that? Now Go doesn't do that with inheritance. Go does that with type embedding. And I want to show you, I've got two pieces of code to give you, to show you how type embedding works in conjunction with the methods and the interfaces and all that polymorphic behavior. So here's that code, that new code sample, but we're using the same things that we've been building on. Here's my notifier interface, declaring that we have a notify method. Here is a user type, same user type that we've been using. Here is an admin type, but admin type's a little different than before. You're going to see here that in the admin type, what I've done is I've embedded the user type. The best way to think about this is that the admin type now has an inner type, and the inner type is of type user. The inner type will always exist in and of itself inside of admin, inside of what I would call admin as an outer type. So now I think of admin as the outer type, and user, in this case, is the inner type. That is what's being embedded. Now watch this, because this is really cool. I'm implementing the notifier interface through this notify method on a pointer receiver of type user. So we still have pointers of type user implementing the notifier interface. And we've embedded the user type in the admin type. So again, user is an inner type of the admin type. I still have my same function down here, which accepts values of type notifier. Any value that implements the notifier interface can be passed in here. And again, through the interface value, I can execute that method's behavior. Let's look at main. So here in main, I'm declaring and initializing a value of type admin. And inside of admin, I'm also creating a value of type user and setting it to the inner type. The inner type always exists within and of itself, and I always have access to that inner type. In the case of this initialization, I'm specifying the name of the inner type and creating a value of that inner type. And so I'm able to, in this one statement, create a value of type admin initializing both admin's fields and the inner type directly. However, only the user has implemented the interface. The outer type, if we just look at the code, has not implemented the interface. Yet this code is going to run. I am able to pass the address of this admin type, and it implements the interface. Why is that? Because something really special in Go as it relates to type embedding. Inner types, the identifiers for the inner type. In this case, the notify method that is part of the inner type gets promoted up to the outer type. We were able to extend user by embedding it into this new type, and everything that user is can be promoted up. And so therefore, since the notify method implemented by the inner type gets promoted to the outer type, admin pointers of type admin also implement the interface. And so I didn't have to worry about implementing the interface at the admin level. I get that for free because of type promotion. Now, the last thing I want to show you here, well, let me show you one other thing as well. I told you that the inner type is always there in and of itself. That means that I can take from my admin value, and I can access the user type and call the method through it. So look what I've done here. I've passed the pointer of the outer type, admin, to the send notification function, which is executing the behavior of the inner type because it got promoted up. And here I'm calling the notify method through the inner type directly. This is a direct call via the inner type to that notify method. It shows you that the inner type is there. And this is showing you how that method, notify method, is also being promoted up. Look at that. I'm going to call notify from a value of that outer type. And it's the same over and over again. That is the only implementation of notify we have. Call it directly, call it through the promotion, and call it through the implementation of the interface. I want to show you one last thing here. Here's our notify interface. Again, here's our user type. Here's our admin type embedding user, making it an inner type. And this time, the inner type user is implementing the notify like before. But now, the outer type, admin, is also implementing the interface. Again, with a pointer receiver. So this time, not only does the inner type implement the interface, so does the outer type. So what happens in that case? Well, I'm creating my admin value, just like I did before, initializing the fields from admin, initializing the inner type directly. And now, when I pass the pointer of the admin type through to the send notification function, which implementation am I going to see? The inner types or the outer types? When I do that, I see the outer type. What has happened here? Well, because the outer type has also implemented the notify interface, the inner type's implementation no longer gets promoted up. The outer type's implementation now overrides that. Yet, the inner type is always there in and of itself. So this time, when I call the send notification function, passing a pointer of type admin through, it implements the interface because it has implemented the interface, and we get that behavior. But I can still call the inner type's implementation of notify if I go through user. And here, this time, I'm getting back to the admin's implementation because admin has overridden the inner type's implementation. So here you're seeing now how we can extend a type. I've extended user. I can leverage everything that user's done through type promotion to the outer type, and I can always override anything that that inner type has done by implementing what I need to override myself. And so here are core aspects of object-oriented programming built in Go, without all the hoopla of extra declarations. It's all about just writing code that does what you need, and it all happens very seamlessly, very intuitive. So that's as quick as I can kind of show you in Go how Go is an object-oriented programming language and some of the constructs behind how the type system works, methods, interfaces, and type embedding to allow you to take object-oriented patterns and apply them to your Go programs.
That was really good, Bill. Thanks for staying up so late. It's like 11 p.m. for him there. So he graciously agreed to take this session. And I was like, are you okay with that? And he agreed for that. So thanks a lot for taking time out and speaking to us. That definitely helped.
Not a problem.
Not a problem. Not a problem. All right. All right.